Hi, Algebra 2 classes. This is Mr. Pang. So first off, I want to say I miss you. I miss being in the classroom. But the rest of the year, there will be video lessons. So hopefully you guys are able to pick these up. So I'm going to start off with the next unit, though. So this is the second part of the trig unit. So all the notes I'm going to go through by day. So this is for the first day of trig part 2. Um, so this lesson, let me get the notes up. Hopefully you guys print out the notes. Um, is going to consist of, again, sine, cosine, tangent. So we saw that in part 1, but we're going to see 3 additional trig units that are going to be the reciprocal of sine, cosine, tangent. Now, before I talk about which one's which, I wanted to introduce what those 3 trig functions are. So we have cosecant, we have secant, and we have cotangent. Now, here though, when you guys work with these trig functions, they're normally going to abbreviate those 3 reciprocal functions. So when we do cotangent, if you see the letter COT, that's short for cotangent. SEC is short for secant. Now, for cosecant, though, I wouldn't do COS because we already have one, which was cosine. So the 3 letters you can use to abbreviate cosecant are the C, the S, and the C. So if you see CSC, that's short for cosecant, okay? So these 3 trig functions are also going to be ratios with respect to a right triangle. So this should be a right triangle, okay? Now, here though, before I talk about the ratios of the trig functions, I do want to take some time to talk about the Pythagorean triples. Now, Pythagorean triples come from Pythagorean theorem. So you guys remember a squared plus b squared equals c squared. So here in this case, though, these numbers I'm going to write out in terms of triples. So when I put it in a squared plus b squared equals c squared, that forms your right triangle. Okay, so these are the common ones that you need to remember, though. This is from geometry, by the way. So 3, 4, 5. We could also do a 5, 12, 13, 7, 24, 25. And then the other one is 8, an 8 right there, 15, 17. Okay, so the reason why I want to talk about these triples for a moment is it will save you time in calculating the missing side of a right triangle. So let's say you have 2 of the 3 sides. Instead of using a squared plus b squared equals c squared, if you know these triples by hand, it will save you a lot of time. So here, though, this is how I can understand this, though. So if I wanted to demonstrate 3, 4, 5, you just simply plug in 3 and 4 into the a and the b. So 3 squared plus 4 squared equals. Now I'm just going to go ahead and check to see that this does work out, though. The 5 would be in the place of c. So when I calculate this, so you guys can see that's 9 plus 16 equals 5 squared 25. You see how 25 equals 25? That right there is why those are all triples, because it works on a squared plus b squared equals c squared. Some things to consider, though, when you guys are working with these triples. Let me circle the last number. So this is going to be the largest number in your triple. That's going to always go in the place of your hypotenuse, your c. So just keep in mind that that's how a triple works, okay? Now, before I talk about the ratios, there's something else to consider. You can also do multiples of these triples. So let's say I times each of these by 2. So if you had a 6, 8, and a 10, that's another variation of the 3, 4, 5. If I were to plug these numbers back into a squared plus b squared equals c squared, that's going to form a right triangle. Okay, I can do the same with this next one, double that, 10, 24, 26. This is another triple. It's just a variation of 5, 12, 13. Here, let me just do it a couple more times, 14, 48, and 50. That would be from 7, 24, 25. And here I'm just running out of room. If I double these numbers, 16, 30, 34, that's also going to be a variation of 8, 15, 17. So those numbers would also fall under triples. It's just multiples. I just times it by 2 from the originals to get those triples. Okay, now, once you have that understanding, though, we'll revisit this when we get to the first example below. I want to talk about the ratios. Okay, so we talked about sine, cosine, tangent in the first part of trig. Remember SOHCAHTOA? We can use that to help us express the ratio of each part for the right triangles. So remember for sine of theta, so that's the reference angle. Here we would say for sine of theta, recall, it's opposite leg over hypotenuse. Okay, so here I use letters to translate that. So the opposite leg I chose as y, because remember that's the vertical leg. And then here's the hypotenuse is your radius. That's why I use r. So you can think of this as y over r. Let's actually make this a little bit better. So y over r is the opposite leg over hypotenuse, sine of theta. Now, if I do cosine of theta, that's adjacent leg over hypotenuse. So I choose x to be the adjacent leg because it's the horizontal leg. And then again, over the hypotenuse, in this case, the radius, x over r. And then for tangent of theta, opposite leg over adjacent leg, that would be y over x. Okay, that's a y right there. So that right there is just recapping the first three. Now, when I talk about the new trig functions, remember I said CSC, that's short for cosecant of theta. Notice the way that it's written. It's now hypotenuse over opposite leg. You see how I flip the sine ratio? Cosecant is going to be the reciprocal of sine. Okay, so here if I want to express the ratio, this would be r over y. Now I just said that cosecant is the reciprocal of sine of theta. So here another way to understand it, this would be equal to 1 over sine of theta. So that's how I can understand cosecant. Secant of theta, if you look at the ratio, it's hypotenuse over adjacent leg. So if I were to write the letters, it would be r over x, so radius over the adjacent leg. If you see that, if I compare that to cosine of theta, you see how I flipped the ratio? So secant of theta is the reciprocal of cosine of theta. So I'm going to say 1 over cosine of theta, okay? And then here we have one more for cotangent of theta. Do you see how I flipped the ratio for tangent of theta? So I would then say for this one, adjacent leg over opposite leg. So that's going to be x over y. So here a way to think of this, the cotangent of theta is simply the reciprocal of tangent of theta. So it's going to be 1 over, we're going to T right there, sorry, 1 over tangent of theta. Okay, so when we do the next set of examples, just keep in mind this is how we're going to set up the ratios for each part to understand which two sides of the right triangle you're working with. Okay, so here's your first example. So when you see this problem on your homework, so by the way, your homeworks are going to be worksheets for the most part, so that's what's nice about these problems. This one, we want to evaluate the 6 trigonometric functions of angle theta. So here, there's the reference angle. This is my theta, by the way, okay, which passes through the point -8, 15. Now here, though, currently they write that as a coordinate, but just keep in mind, though, that -8 represents the x, in this case, the adjacent leg of your right triangle, okay? And then here, though, the 15, so see how that's the y, that's going to be the y in that case for your right triangle. So before I set up the ratios for each part, though, you do want to also get the hypotenuse of the right triangle. So in this case, that's the radius. Okay, let me just label this. So this was x, this was y. Okay, now here though, you could do a squared plus b squared equals c squared to calculate the radius. Okay, so here you could do -8 squared plus 15 squared equals r squared. But let me go back up. You see how if you know your Pythagorean triples, you see how the 8 and the 15 were already used. Here's my missing length of that right triangle. The hypotenuse in this case would have been 17. So here though, I would say right here though, just to save room, I'm going to say because by an 8, 15, 17 triple, here I know that r in this case, the hypotenuse, the radius is going to be a 17. Okay, so now that you have all 3 sides of the right triangle, we are ready to then express the ratio. So here, keep in mind though, let's do the basic ones first. The first 3 is a recap. Sine of theta, remember, that's opposite leg over hypotenuse. So you see how this is the opposite leg because it's across from theta, right? So I'm going to say 15 over 17. That's going to be sine of theta. Cosine of theta, remember, it's going to be adjacent leg over hypotenuse. So that's going to be a negative 8 over a 17. So there's your next ratio. Tangent of theta, remember it's opposite leg over adjacent. So it's going to be 15 over negative 8. Okay, so those are pretty basic. We've done that before from the previous unit. Now here to get the new functions, remember I just simply take the reciprocal of the three trig functions. So if you recall, cosecant of theta is the reciprocal of sine. So if I flip this would be 17 over 15. Secant of theta is the reciprocal of cosine of theta. So if I flip that around, that would be 17 over negative 8. And then here finally we have cotangent of theta, that's the reciprocal of tangent. So here I'm going to have negative 8 over 15. Okay, so I can't stress this enough. If you know your triples, that will save you some time, but you don't have to do Pythagorean theorem if it's one of those 4 triples I introduced to you earlier. Okay, now there could be a question where they're going to actually evaluate the 6 trigonometric functions given the angle, the reference angle, which in this case is 270 degrees. Now this is where you have to remember from your unit circle where 270 degrees takes place. Now here, just to remember, it's actually one of your quadrantal angles. It's going to be touching one of the axes. Now remember, this was 0, 90, 180, so here's 270. 270 degrees is going to be right there, okay? Now here, this is what I want actually for this 270 degrees. I actually want the coordinate. So if you recall, in a unit circle, we have a radius of 1. So I went down 1, so this is a coordinate of 0, comma, negative 1, okay? Now that's actually very relevant because here we can then use this to help us answer sine and then cosine. Remember, for your cosine of theta, that's going to be the x-coordinate. The sine of theta is going to be the y-coordinate. That's if you have a radius of 1. That's what we have here. So I can immediately answer sine of theta. That's the y-coordinate. It's negative 1. For cosine of theta, that's the x-coordinate. That's going to be 0. Okay. Now, if I want to get tangent, remember we do opposite over adjacent. So this would be the vertical leg over the adjacent leg. So in this case, y over x. So if I did negative 1 over 0, I'm going to write it up here. That's going to be the setup, but that's not my final answer. We can't divide by 0, so here's the ratio for tangent of theta. We say it's undefined, okay? So that right there would be your setup, your ratios for the first 3. Now here, though, when you do the other 3, though, remember we want to do the reciprocal. So here you can think of this as negative 1 over 1. If I do the reciprocal of that, well, that's 1 over negative 1, which is, again, negative 1. So there's my first answer for cosecant theta. Here, for this one, think of this as 0 over 1, right? So if I do the reciprocal of that, that's going to be 1 over 0. So here, again, you're going to have undefined for secant of theta. UND short for undefined, by the way, so I'm just going to say UND. Cotangent of theta, now this one's tricky. You got to go back to the original setup. So if I flip negative 1 over 0, that's 0 over negative 1. That's going to get me a ratio of 0, okay? So something to consider when you guys are doing your ratios, this is actually really helpful. Anytime we are faced with 0, if I want to do its reciprocal, it's always going to be undefined, and then vice versa. If I get undefined, the reciprocal, that will always be 0. So you may want to make a note of that, those in the future when you guys are faced with that situation. And that's what happened in that case right there. Okay. Now here, though, when you reach the back of the notes, here I do want to take some time to explain when your trig functions are going to be positive versus negative. So this is where you have to remember in your coordinate plane. Now, back in the previous unit, I showed you, let me just draw it over here. The fact that your x and your y's on the first quadrant are both positive, positive, positive. In your second quadrant, your x is negative, positive. Third quadrant, both x and y are negative. And then in the fourth quadrant, x is positive, y is negative. Okay, so that's what I showed you in the first part of the trig unit. Here now, we're going to look and see what's happening with the other trig function, so it's reciprocal. So here, though, if we're in the first quadrant, let me just say this, everything's going to be positive. So here, for that reason, when I look at the x and the y, both of them are positive, and then positive over positive, you're going to get positive. Okay. Now, if I go into the second quadrant, this is the tricky part. Here, if I look at my x and my y, do you see how my sine is the y? That's positive, so that's going to remain positive. But cosine is negative, right? So therefore, if I did positive over negative, that's going to be negative in this case. So that's going to have effect on tangent and cotangent of theta, negative. In the third quadrant, now here both sine and cosine will be negative according to the coordinate. Now when I do negative divided by negative, here in this case tangent would be positive, so same with cotangent, positive. Okay, and then finally when I look at the fourth quadrant, so for sine and cosecant, it's negative. Cosine and secant are going to be positive, so if I do negative divided by positive, that's going to be negative in this case. Okay, now this is actually something that's relevant when you get into pre-calculus. So I want to make a note about something. So you guys see how I'm going to write out this acronym, A, S, T, C. So here the in pre-calculus say all students take calculus. Now that acronym is really helpful because here this tells you when your trig functions, which trig function is positive. Okay, so here though, the A applies to the first quadrant. So do you see how all the trig functions are positive? In the second quadrant, do you see how sine and cosecant are the only ones positive? In the third quadrant, this is going to be for T. You see how tangent and cotangent are positive? And then here though, for the fourth quadrant, C, that's saying cosine and secant. That's the those are the trig functions that are positive. So this is actually going to be really useful when you get into pre-calculus, because then that way you remember which trig function is positive in which quadrant. Okay. Now here's the idea though with this problem though. So we are going to be using the coordinate plane, sorry, to help us evaluate these problems. Now this is a lesson I showed you guys right before school's closed. That day 8 lesson from part 1. So I'm going to be doing a few steps. I'm going to first do the angle of rotation and then draw my reference triangle, and then using special right triangles to then label the sides of the right triangle. Remember that whole radius being 2. Let me actually make a note. So I'm going to be using a radius of 2 to help us out with these problems when we do that right triangle. Now then you're going to have all the sides, and then you're going to be able to evaluate the trig function. Now the idea is you're going to practice it with the reciprocals, right? So we're going to have cosecant of 11 pi over 4. For part B, we're going to have cotangent of negative 2 pi over 3. Now here though, remember how I showed you guys the angle of rotation? So here though, we have 0, 1 pi, and then here though, that's going to be 2 pi. Now I'm going to put it in terms of fourths, okay? So here we know 4 over 4 is the same as 1 pi. Over here, I'm going to have this one as 8/4 pi. Okay, now I'm going to rotate this counterclockwise, so then that way you guys can see where 11 pi over 4 is. Now this one's actually going to exceed 8 pi over 4. So I'm going to go one full rotation, and then I'm going to keep going. Now here though, I'm actually going to go all the way to the second quadrant, because if I kept going, here you guys see how that's going to be 3 pi or 12/4 pi. So 11 pi over 4 is going to be close to 12/4 pi. Now I'm going to go ahead and draw my terminal ray. And then here though, from that point though, you can go ahead and draw your perpendicular segment. There's your right triangle. Now I'm going to go ahead and label the reference angle. So recall, this was at 11 pi over 4. And then if I compare that to 12 pi over 4, here's my reference angle. The reference angle is going to be pi over 4. Now in degrees, it's going to be 45 degrees. Remember, pi is 180, so if I do 180 divided by 4, that's 45 degrees. Now here though, let me go ahead and redraw the triangle down here so I have the room. So let me actually take this out so that way I have room. Here though, what we want to then do is we're going to use that reference triangle I just drew out. So there's the reference angle. This was pi over 4. So let me actually fix that. Oops, I didn't mean to erase the triangle, but I see that I'm going to have a 45-degree angle for the reference triangle. So this is actually going to be a 45, 45, 90. Now, if you guys recall, I said the radius or the hypotenuse is going to be a 2. And then this is where you have to remember your properties of a 45, 45, 90 triangle. So if the hypotenuse is 2, both the legs are going to be square root of 2. Now here, though, this is where you have to remember your signs, though. So in the second quadrant, here your x is negative. So here I'm going to have a negative square root of 2, but the y is going to remain positive. So I'm going to have square root of 2. So here now I am ready to then evaluate cosecant of 11 pi over 4. Now remember, cosecant is the reciprocal of sine. Sine was opposite over hypotenuse. So if I do the reciprocal, it's going to be hypotenuse over the opposite leg. So here, though, I'm going to say 2 over the square root of 2. Now here I'm not done, though, because here I have to rationalize it, so I can't have a root on the denominator. So I'm going to times this by a root 2 on the top and bottom. So I'm going to have 2 root 2 over 2. The 2's cancel, so I'm going to have square root of 2. So that right there, guys, well, that was for part A. That's going to be your ratio for cosecant of 11 pi over 4. Okay, so you've done this before, though, but you're just now working with the reciprocal trig function. So just keep in mind that that's the idea. You could also have a case where you're going to rotate clockwise. Do you see that negative? So remember, this is 1 pi, that's 2 pi. Now I'm going to make it in terms of thirds. So here the 1 pi is the equivalent of 3 over 3. Now remember, this was 2 pi, so that's going to be 6/3 pi. Now I made a mistake, though. Remember, we're going clockwise. I can fix this. It's an easy fix. So I'm going to go this way. So this would be a negative, and that would be a negative. Okay. So in this case right here, I'm going to start down. I'm sorry, on the x-axis, I'm going to go this way. Now the negative 2 pi over 3, though, is closest to negative 3/3 pi. So it's going to be in the third quadrant this time. So there's my rotation. Now I'm going to draw my terminal ray to get the angle of rotation. And then here, draw a perpendicular segment from that, though, to get the reference triangle. There's the reference angle. Now here, though, this was at negative 2 pi over 3. So that means here's the reference angle. It's going to be a pi over 3. Now here, though, as a degree, that's going to be 180 divided by 3, which is 60. So my reference angle this time is going to be 60 degrees. Okay. So now that you have your reference triangle, let me redraw the right triangle over here. Had a reference angle of pi over 3, or 60 degrees. So there's your reference angle, and that means I'm going to be using a 30, 60, 90 triangle. Now, once again, you're going to be using a radius of 2. So we're going to have a radius of 2 again, always a radius of 2, hypotenuse. Now, this is where you have to remember a 30, 60, 90 triangle, though. So the short leg is always going to be half as much as the hypotenuse. It's across from the 30-degree angle, so this would be a 1. And then here, though, the long leg is across from the 60-degree angle, and I times by root 3 from the short leg to get the long leg. This would be square root of 3. Now here, don't forget about the sign. So since we're in the third quadrant, both the x and the y are negative. So I have a -1, negative root 3. Now when I do cotangent, remember the reciprocal that it's going to be in terms of is tangent. So remember, tangent is opposite over adjacent. So cotangent, if I do the flipping, it's going to be adjacent leg over opposite leg. Okay, so the adjacent leg in this case is -1. The opposite leg is negative root 3. Now here, if you guys can't remember which one's opposite or adjacent, here the leg that's always across from the reference angle is opposite. You see how this leg is touching the reference angle, so that's why that's adjacent. So that's how I got that set up. Now the negatives can cancel, and then here the I don't want the root on the denominator, so I'm going to go ahead and rationalize this. So I'm going to times both the top and the bottom by square root of 3. The negatives go away because a negative and negative is positive. So I'm going to have a root 3 on the top. And then on the bottom, you're going to have root 3, and root 3 is just a 3. So here's my ratio. The cotangent of -2 pi over 3 is going to be root 3 over 3. Okay. Lastly, once you guys get the idea of the rotations, here though, in the last example, they're going to ask you to first sketch out your triangle, and it will indicate which quadrant you want to draw the triangle. Now this is really important though. They'll give you a ratio for one of the trig functions. So in this case, they gave you secant of theta. That's equal to 5/3. Now I can actually go ahead and answer that on this one right here though. So secant of theta is 5/3. Okay, so I have to find the other 5 using that ratio. Now because we're in quadrant 4, here I'm going to actually draw a reference triangle. I'm going to make a note. So draw So guys, here I just want to say this though. It's really challenging for me to write and talk at the same time though, so I'm just doing the best I can. Forgive me if I'm not able to write neatly though, but I'm doing the best I can. It's just hard to do it when it's not flat on a table. So draw a reference triangle is what I'm going to do first. So go ahead and do the terminal ray first. And then here though, you're going to then, from this point, draw your segment so it's perpendicular to the x-axis. So there's my reference angle. Now here in this case, I don't have to get a value like I did in the previous example. This is not a special right triangle. So here though, we have to figure out where to put the 5 and the 3. So this is where you have to go back to a secant ratio. Remember, secant is the reciprocal of cosine. Cosine was adjacent over hypotenuse. So if I do the reciprocal of adjacent over hypotenuse, that's hypotenuse over the adjacent leg. So in this case right here, the 5, you guys see, is going to be the hypotenuse. So I'm going to put the 5 here. And then here, though, the adjacent leg is 3. That's going to be for the horizontal leg, 3 right there, okay? Now here, though, I do need this length right here, though, to help me get the rest of the answers. Now, this is why I told you guys about Pythagorean triples earlier. If you go back up to the front, here, though, do you see how one of the triples earlier I listed that was 3, 4, 5? So here's my conclusion for this one. So to get this missing leg, I can go ahead and make this remark. I can say by a 3, 4, 5 triple. Here in this case, I'm going to say y equals 4. Okay. Now here though, it's not just going to be a 4 though. Here it's actually going to be a negative 4. Let me use the red one so then that way you guys can see this. It's a negative 4 because in the fourth quadrant the y coordinate is negative. Okay. So now I actually can then get the rest of my answers. So if I were to first, let's do sine again. Sine of theta, remember, is opposite leg over hypotenuse. So here's my answer for sine of theta, negative 4/5. Okay. Now cosine of theta, I could use the triangle. I know it's 3/5, or just go to secant of theta, take the reciprocal of that. That's 3/5. Okay. And then for tangent of theta, that's going to be opposite over adjacent. So it's going to be negative 4/3. Okay. And then here, though, for cosecant of theta, that's just the reciprocal of sine. So it's going to be 5/negative 4. And then here, though, for cotangent theta, just do the reciprocal of tangent. So that's going to be 3/negative 4. Okay. So that right there, guys, concludes the first lesson of Trig Part 2 unit. So the homework is going to be a worksheet. So this you can print out from the course locker in the Chapter 9 Part 2 folder. You could also access it on the Google Classroom. So this will be homework number 36. Okay, so good luck, and I will see you guys next time.